Alright, hi, so we're going to get into section 2.2. There's really only a couple main topics I want to talk about. The title deals with algebraic expressions. There's only a couple things in there that I really want to get into, and that's the order of operations. We'll start there, and then we'll move into the distributive property and combining like terms, how to simplify the algebraic expressions. Okay, so those are two main things. So we'll start with the order of operations. The order of operations, you guys probably have seen this before, this abbreviation called PEMDAS, P-E-M-D-A-S, or please excuse my dear Aunt Sally, right? Most people have heard that before. I don't really like this, the way this is written out in a list though, the order of operations, because you got your parentheses, exponents, multiply, divide, add, and subtract. And it appears that you do those in that order, but that's not always the case. And so what I tend to do is think of them in layers, okay? So instead of in an order, think of them in layers, what you do first, what you do second, what you do third, and so forth. The bottom layer, which is the last thing we do, is the adding and subtracting, okay? So add and subtract is always at the bottom. We do that last because the other operations are derived from that one, okay? Now, the next layer up is going to be your multiplying and dividing. And the reason it's the next layer up is because multiplying is really just a repeated addition. So it's a shorthand way of writing addition. So we do the multiplying first because we're really doing addition anyway, and then we put the addition in after. So multiplying and divide. Okay, I'm abbreviating these, but that's your next layer. That's multiplying and dividing is always going to come before adding and subtracting. Okay. The next layer up is going to be your exponents, because an exponent is essentially a repeated multiplication. Okay, so you're going to do the exponent, which really just multiplying anyway, and then you do the multiplying. So again, I'll abbreviate. So we got exponents. And then the final layer, which is really the first thing we do, are parentheses, or different grouping symbols. Parentheses, brackets, braces, square roots, absolute values, all these things are called grouping symbols, but we just use parentheses because the P is nice in the abbreviation, okay? And they're the most common ones, honestly. So those grouping symbols we use to separate things that we want done first for a particular reason. In other words, you may have a situation where you want to do an addition before you do an exponent. And in that case, you put parentheses around that addition to say this has to be done first before we move on to the rest of the order of operations. Anything inside the parentheses is done first, and in the parentheses, you then follow the other order of operations. Now, a couple things to keep in mind. You always do the grouping symbols inside out. So if you have grouping symbols inside of grouping symbols, you always go from the inside out. Okay, so inside, out. Start inside, work your way out. With multiplication and division, you're always going to work those from left to right. Okay? So there could be times where division actually comes before multiplication if it's listed on the left. Okay, so left to right. And the same can be said about adding and subtracting. We always work those from left to right. Okay? And so there are times, again, where subtraction may come before addition, or addition before subtraction. It just depends upon which one occurs on the left. So we go leftmost and work our way to the right. Okay, so let's work through just one quick example. I'm going to pull one out of the textbook here. And so I'm going to use 10 squared minus 100 divided by 5 squared times 2 minus 3. Now notice in this example I have no grouping symbols. There's no parentheses or absolute values or anything like that, so I don't have to worry about that. I can jump right down to the exponents. technically we should do one operation at a time. If I start combining operations or doing two at a time, I can make some pretty significant mistakes. There are times where it's okay to do that. In this particular example, there's two exponents. Technically, I should work them left to right also, or inside out, depending upon how they're layered. But in this case, you could actually do them at the same time because they don't interact with each other. Okay, they're separated by other operations. Again, here it's okay, but it's not always safe to do that. So I'm going to go ahead and do this one step at a time and show you how that would work out. So I'm going to start with the 10 squared. Of course, 10 times 10, 10 squared is 10 times 10, which is 100. So I get 100 minus 100 divided by 5 squared times 2 minus 3. The next operation is the other exponent. 5 squared is really 5 times 5, which is 25. So this is 100 minus 100 divided by 25 times 2 minus 3. Okay, so again, we're doing one operation in each step. Now, the order of operations would say once the exponents are done, we jump down to multiply division. It's the layer that we're on, not a specific operation. And in this layer, we always work left to right. So when I look at these operations, the subtraction I can skip. The division and the multiplication are the ones I need to focus on in this layer, and the subtraction I can skip. So we're debating between the division and the multiplication, and we're going to actually choose the division first, again, because it is on the left. Okay? So 100 divided by 25 is 4. So that combination right there makes for a 4. Everything else comes down, so I need the 100 and the minus, and then the times 2 and the minus 3. Okay. The next operation, staying in the same layer, is the multiplication. So 4 times 2 is 8. Okay, so this combination here gives me 8. Keep the 100 and the minus and the 3. Now we have two subtractions. Again, we jump down to this bottom layer, we go left to right, so we do 100 minus 8, which is 92. Subtract the 3 off, and that should give us an 89 as a final.